All right, welcome to the next lesson on Unit 2 about proving lines parallel. This one is going to seem like a whole bunch of old information because it kind of is. I guess maybe that's refreshing. But what's new about it is we're going to start taking all these reasons or all these types of angle relationships we've been seeing before, like corresponding angles, and we're going to talk about how to prove lines parallel if you know the corresponding angles are congruent, for example. So the types of angle relationships we're looking at: corresponding, alternate interior, same side, or sorry, consecutive interior. Those are all old news, but what's new is now we're going to use those and to actually do proofs. So I guess it's the proving that's what's new. So corresponding, again, old news. The only thing about it is it's kind of written backwards from what you're used to before. Okay, we saw this before. If two parallel lines are cut by a transversal, then the corresponding angles are congruent. Now we care more about the backwards way, which is if the corresponding angles are congruent, then the lines are parallel. So we just reverse the if and the then. In this case, you would know about the angles first and then conclude, oh, well, then the lines must be parallel. Because remember, in order to be called corresponding angles, angle 1 and angle 3 here, do not have to be these lines don't have to be parallel in order for them to be called corresponding angles. 1 and 3 are corresponding just because of where they are. But if it turns out we find out they're congruent, then that forces A to be parallel to B. That's kind of the new thing here. But since we had both the forwards way, it was if two parallel lines are cut by a transversal, then the angles are congruent. And this one, if you've got corresponding angles that are congruent, then the lines are parallel. We're going to write this as a biconditional. This is one of those times, and we have a bunch of these today, it's one of those times when the original and the converse are true, so we can write them, zip them together kind of like this. If two lines are cut by a transversal, the corresponding angles would be congruent if and only if the lines are parallel. I kind of wish this would have been when. Can I just change that right now? Is that going to bother anybody? Because I don't like there being extra ifs in my biconditionals. That's all it should be. When two lines are cut by a transversal, the corresponding angles will be congruent if and only if the lines are parallel. So the condition about congruent angles, corresponding angles being congruent, and the condition that the lines are parallel are going hand in hand. Now, on your theorem sheet, you're not going to have postulate 3.1 and postulate 3.4. We're going to write them together as one thing, which I think is going to make it a lot less confusing. You don't have to name the correct 1.3.1 versus 3.4. It's just all going to be one thing. We're going to call it corresponding angles. Okay, so that's true for all the rest of these too. So the one about alternate exterior, you've seen this picture before. You know these are called alternate exterior. Before it was, well, if the lines are parallel, then alternate exterior angles are congruent. Now it's, well, if you find out these angles are congruent, the big light bulb there is, well, then these lines must actually be parallel then. Same with consecutive interior. If this 4 and this 5 turn out to be supplementary, that'll force P to be parallel to Q. And with alternate interior, if 8 and 6 are congruent, those are alternate interior. If those are congruent, then we'll be able to prove that P and Q are parallel. Right now this is a whole lot of talk till we actually do something, so here we go. All right, so here's the picture. It doesn't tell us about anything being parallel. We're supposed to be trying to find that out. What if we knew 1 was congruent to 4? If you knew 1 was congruent to 4, what would that be able to help you establish? Sorry, technology thing there. 1 is congruent to 4. Okay, so 1 is right here. If I knew that was congruent to that, okay, there's a bunch of stuff going on in this picture. There's a zillion transversals and lines that could possibly be parallel. The conclusions would be something like, well, then I know line blah is parallel to line blah. So what's my blah that I'm going to fill in there? Which lines does that make parallel? Well, the way to sort this out, because there's so much going on, is look at the vertex of the angles we're talking about. We're talking about this vertex here and this vertex here. When you connect those two vertices, draw that connection there. Think about that. Okay, this is really hard to follow this perfectly on this tablet thingy. That's the transversal. The connection here is the transversal. And the other lines that are part of those angles, right? So the angle 1 here and angle 4. Angle 1 is on of course, touches the transversal, but then it touches this other line. So it's touching this line, and 4 is touching this line. So these are the lines we've just found to be parallel. In other words, 1 and 4 are corresponding angles along lines L and M. Those are the parallel lines, and this is the symbol for parallel. Why do we know? Oh yeah, I've already said that. That's kind of the easy part, is how did I know that in the first place? I kind of would have known that first, actually. It makes more sense to write them down in this order, but you kind of know this first. I said it was because, if you look at, whoa, I'm accidentally clicking. If you look at the way 1 and 4 are kind of arranged, and this is the part we've done before, 1 and 4 are corresponding angles. Okay, so now when you go to part B, you're supposed to forget all this stuff. Oh, I could have a bigger eraser, it would kind of help. All right, so for part B down there, okay, totally different situation. This is not a step-by-step kind of proof. These are different problems. All right, if 6 is congruent to 4, so let's mark those. If 6 is congruent to 4, I think the first thing that's easiest to do is go, well, what kind of angles are they? And there's only like 4 different types. We went over this 2 classes ago. Are they corresponding? Are they alternate interior? Are they alternate exterior? Or are they consecutive interior? These, if you look at the sides of these angles here, this little Z kind of shape here, this is alternate interior. They're on alternate sides of a transversal, and they are inside some parallels. To find which lines we're talking about, which is kind of the new hard part here, think about the connection of the vertices. Angle 4, angle 6 vertices are there. Here's the connector, so that's the transversal. So that means the parallel potentials would be this one and this one. Those are the other angles that those lines are on. So we're talking about JK, and I'm serious. All right, and why were they? What's the shape of those angles? It's alternate interior. Okay. Same picture. There's a bunch of these. These are good. 2 plus 3 equals 5. Okay, how do I mark that? 2 and 3 are right here. 5 is kind of over here. Well, you know what? 2 plus 3, since they're adjacent and stuck together like that, when I'm talking about 2 plus 3, it's really that. 2 plus 3 can be marked as that thing, and that's supposed to be equal to 5. So these two little red arc angles are equal. The vertices of those are here and here. So this is the transversal. The other angles, the other sides of those angles, here's the side of angle 5, here's the side of angle 2, or 2 plus 3 really. The other side I haven't marked yet with the transversal. So there's the H pattern we see in all these. Angle 5 and angle 2 plus 3 are corresponding altogether. And what is parallel from that? Well, it's L and M again. Those are the ones that are marked up there that are parallel. Let's see if I can make a bigger eraser here with that. Ooh, that'll make my life go more efficiently. Okay, and the next one, 6 and 8. All right, 6 is here, 8's over here. Here's a vertex, connect those, connect the vertices. That's a transversal. The other side of 6, the other side of 8. Forget about everything else in the picture, which is kind of hard to do. Maybe I should use the highlighter. I'll do that next time, see if that's easier. Because there's a bunch of these. We'll just keep doing this. I'll do the highlighter next time. All right, 6 and 8 appear to be corresponding. And they're corresponding on these two parallels. It would look like L and M would be the parallel. Okay, I think the eraser works on the highlighter. We'll try that next time. I think that'll be easier to see. All right, so the next one, 2 plus 3 plus 8. Oh my gosh. 2 plus 3, yeah, was right here. I can't really mark 2 plus 3 plus 8 in one place because 2 plus 3 is on this vertex. 8's all alone kind of over here on this vertex. I can't really mark it with the same marking because they're not equal. They add up to 180. But these are the two angles I'm talking about. I'm talking about that one and that one. Try highlighter this time, see if this is better. So here's the connection of those vertices. So that's the potential transversal. And the other sides of that angle, okay, here's the line that's the other side of angle 8. Here's the side that's the other angle, part of the angle 2 plus 3. I'm kind of combining 2 plus 3 all into one thing on this. I'm not really thinking ever about 2 plus 3 separately. 2 plus 3, I have to call them 2 plus 3 because of this other crazy line that's kind of in my way. Kind of wish that wasn't there and I could just call this one great big angle, but I can only refer to it as 2 plus 3. All right, so now looking just at the yellow stuff, you see the H pattern. These two angles, the 1 arc and the 2 arc angle, those are consecutive interior now. And they're consecutive, that's an I, interior, and their consecutive interior between these two parallels, which is, again, and I'm being serious, JK. J parallel to K. All right, a couple more of these. I like the highlighter. 9 and 10. All right, 9 is there, 10 is there. Connect the vertices of those two in your mind. Connecting the vertices, I'm looking at that as a transversal. The other side of 10 is here, so let's look at that line. And the other side of 9 is here, so we're looking at that line. Here's the H. Look at that corner and that corner relative on this H. Those appear to be alternate exteriors. And they're alternate exteriors on these two parallels, J and K. Next, 7 and 1. Get through all these, I think, before I run out of time. 7. Oh, let's erase all the junk that had to do with part F. Oh yeah, good. The eraser will erase the highlighter. Magic highlighter erases with eraser. Okay, 7 and 1. 7 and 1 are right there. Let's highlight the vertices. The vertex of 7, the vertex of 1. Well, that's the same angle. So where's the transversal? I can't connect anything. Well, there is no transversal. 1 and 7 don't have anything to do with parallel lines. I even look at the lines they're on. Here's the sides of 7 and 1 all at one time. I don't have an H, I have an X. So the conclusion here is really nothing. I can't say anything special from this information. 7 equals 1, they're just vertical angles. I would have known that anyway, thank you very much. I didn't need parallels. It doesn't help me show anything's parallel because there's no, this angle size doesn't really tell me. It doesn't touch any other lines other than those two, and they're just intersecting. They're no fun. There's no, like if I had angle 8 in the mix, that would get me somewhere, or 4 or 10. You kind of need them at different intersections so you could connect those dots and think about a transversal. But there's no conclusion here, so there's no reason. Okay, and lastly, we have 5 and 4. All right, here's 5. And here's 4, and these are supposed to be congruent. Well, they don't look congruent. They look supplementary. This is saying, what if they're congruent? Okay, this is a little weird. So here's the only vertex. Again, so I'm not talking about any potential parallels because there's only one here. The sides of those things look like this and this. If we have linear pair angles, that's what 4 and 5 are. See, 1 and 7 were vertical. And the fact that they were equal didn't lead me to conclude any new information. 4 and 5 are linear pair. So if linear pair angles are equal, I also knew, I could have thought about this too. I know that 4 and 5 have to add up to 180. If they add up to 180 and they're equal, I know that they're both 90. If you just do some simple arithmetic there. I could say that they both equal 90, or I kind of like it better to say, if they're both equal to 90, they really look like this. They're right angles. They're both equal to 90, so I can just say M is perpendicular to K. I like saying it that way better. Okay, what's the reason for that? I think there's technically a theorem that says if two linear pair angles are congruent, then the lines are parallel. I kind of just want to say, well, that's angle addition postulate. 5 and 4, I know what they add up to. I know that they're equal. I do some fancy algebra. I'm done. I would be happy if you said angle addition postulate on this. Ask me in class if you want to see why, or if you have an alternate reason. There's about 3 or 4 other reasons I can think of that would actually work for that. So that's fine. Last couple. All right. 5 plus 9 is 180. 5 plus 9, what did I just do? 5 plus 9 is 180. So they're not equal, so I'm not going to mark them equal. But I know those are 180. This is kind of a long one. Okay, I got a minute. I know that 5 and 4 add up to 180 because of linear pair, so I'll say that because I know now that 4 and 9 have to be congruent. So we're going to say corresponding. And I'll let you connect the dots because I'm out of time. Just about. That's going to make J parallel to K. We'll talk about why those at class. And the next one, 8 and 4. Here's 4, here's 8. Believe it or not, that's none. You try to connect those on a transversal, there's no connection between here and here. And the sides of the angle don't even talk to that connector anyway. So that's actually none. Okay, I got to pause it here. Stay tuned for part 2.